We're starting with f plus g of x, which we can write as f of x plus g of x. My f of x is x squared minus 1, and I'm going to add that to g of x, which is 2x plus 5. And then we're going to combine like terms, and we have x squared plus 2x plus 4. And the domain of f plus g of x is the intersection of the domains of f and g, and the domains are both all real numbers, so our intersection is all real numbers, which is written as negative infinity to infinity. And we have f minus g of x, which can be written as f of x minus g of x. And my f of x function is x squared minus 1. I'm going to subtract off g of x, which is 2x plus 5. And we're going to make sure we put parentheses around the 2x plus 5 so that we're subtracting the entire function. And then you have to distribute your negative. So we end up with negative 2x minus 5, and then you're going to combine like terms. We have x squared minus 2x minus 6. And our domain is the same as f plus g of x. It's the intersection of the domains of f and g, which is negative infinity to infinity. Now we have f times g of x, and if I felt like it, I actually could write in the domain right away because it's the same as f plus g and minus g. It's the intersection of the domains of f and g, which is negative infinity to infinity. Once you find f plus g, you already have minus g and times g right away. All right, let's go ahead and take our f times g of x and write it as f of x times g of x. And my f of x function is x squared minus 1, and I'm going to multiply it by g of x, which is 2x plus 5. And we need to have parentheses when we multiply the two functions together. And we're going to end up foiling that, so we have 2x cubed plus 5x squared minus 2x minus 5. I just want to double check that. 2x cubed plus 5x squared minus 2x minus 5. Okay, looks good. And we already found the domain was negative infinity to infinity. Now we have f times f of x, which is just your f of x times itself again, f of x times f of x. And f of x is x squared minus 1. And I'm going to multiply it by another x squared minus 1. And we're going to go ahead and FOIL that out. We have x to the 4th minus x squared plus 1. And we're going to combine like terms. We get x to the 4th minus 2x squared plus 1. And our domain is the domain of whatever f is. The intersection with f of x and his own self is his own self from negative infinity to infinity. And now we have f divided by g of x. So f divided by g of x can be written as f of x over g of x. My f of x function is x squared minus 1. My g of x function is 2x plus 5. You can actually factor your x squared minus 1 into the difference of squares, but if I think ahead and I do that, I realize that I will not be able to cancel it out with anything in the denominator, so I'm just going to let that sit just like that. The domain of f divided by g of x is the intersecting domain of f and g, excluding whatever makes your denominator equal to 0. So I know that my overlapping intersecting domain of f and g is all real numbers. It's the whole number line. And then we're going to figure out what makes this equal to 0. So 2x plus 5 is my denominator. I'm going to set it equal to 0. And then x is going to equal negative 5 over 2. But technically that's what x cannot equal. That's what you need to take out of the domain because that's what makes the denominator 0. So I'm going to go ahead back onto my overlapping domain here of all real numbers. and I'm going to take out my -5/2, and then we're going to go write our domain down below. Our domain of f divided by g of x is -infinity up to -5/2, unioned with -5/2 to infinity. Okay, finally we have g divided by f of x, which can be written as g of x over f of x, and that is equal to 2x plus 5 over my f of x squared minus 1. And once again, I can factor x squared minus 1 into the difference of squares of x plus 1 times x minus 1, but it's not going to allow me to cancel with any factor in the numerator, so I'm going to leave it just like that for its simplified answer, and then we're going to go ahead and find that domain. Now, once again, the domain of g divided by f of x is that intersecting domain of both f and g, where both of their domains intersect, excluding whatever makes the denominator equal to 0. So we're starting with the overlapping all real numbers from -infinity to infinity, and then we're going to figure out what makes x squared minus 1 equal to 0. And then you get x squared is equal to 1, and then square root both sides, and x will equal plus or minus the square root of 1, which is 1. And I'm just kind of shortcutting that solving because I'm running out of room. And technically that is what x cannot equal, because if you plug a 1 or a -1 into your denominator, it's going to calculate out to be 0. So we're actually taking that out of our overlapping domain. So I'm going to make some room here to do that. I need to exclude both -1 and +1 from my intersecting domain. So it's going to start from, actually let me back up a little bit, give myself some more room. It's going to start from -infinity and go up to -1. It's going to jump over -1 and pick up with -1 to 1, and then we're going to union that with 1 to infinity, the right side of that graph.